So if you remember on example 6, I said that every single one of these has the same inside function, but a different outside function, and therefore a different rule of integration. All right, so if you see something like this, you might want to rewrite it. Anytime you have a radical, you want to write it as a rational exponent. And anytime you have something written in the condensed notation, cosine squared, it could be helpful to write it in the expanded form. So bring the 2 up front, and you got the sine of 2x times, and now extra parentheses squared, cosine of 2x. So again, we're trying to see layers. We're trying to identify inside and outside pieces. So which factor has more information, the first or the second? The second. So remember, that one's going to contain both the rule of integration as the outside function. So as you walk up to the function, you bump into something squared. So that's ultimately going to be the rule of integration, the power rule. But cosine of 2x has the possibility of being the inside function. You can't just assume that it is. You always have to check. And the checking involves taking the derivative. Okay, so what's the derivative of cosine of 2x? Yeah, negative 2 sine of 2x, right? Same as it was yesterday. And that's the great thing about math. You can kind of leave it alone, come back to it, doesn't change, still works. No batteries required. So we get the critical variable piece. We're only off by a negative 2. So we've got it. So the 2 goes along for the ride. That was there in the beginning. If we generate an unwanted negative 2, we'll have its reciprocal there to neutralize it. And now we move on to the second part. The sine of 2x gets packaged back up inside. And we're on to the rule of integration, which is blob squared. So by the power rule, that becomes 1/3 blob cubed with the same blob, and then plus c. So here's an example of one that has every one of the 3 types of coefficients. You have what I call the rider. You have the correction of the constant multiple. And then the word third came from the rule, the power rule. And those are the maximum number you'll ever have. And so now in the end, you just simplify it. You get negative 1/3, and you can write it back in the condensed notation, and there's your answer. Maybe I'll put a parenthesis around there. Okay, so the cleanup in the last step, it should be easy. All right. Any questions on that one? Moving on, A, B, C, D comes next. There's D. If you look at this one, it almost looks like a misprint, like I'm missing something, right? That's sine of 2x times sine of cosine of 2x. Okay, so here's one factor, and here's another factor. We got 2 factors. Which one has more info? Silly question, right? The second one. So if you work from the outside in, the outermost function is sine of blob. So perhaps that's the rule of integration. Do we know the antiderivative of sine? We do. So that's coming. We don't do that first. We have to check first. There's something inside the sine function. That would be what we'd call u, if we were doing u sub, or the inside function, and we check its derivative compared to the other factor. And of course, we still get negative 2 sine of 2x. So yep, we get the sine of 2x part. There's no rider here except the 1. So we have a correction of negative 1/2. And now we move on to step 2, the rule of integration. What is the antiderivative of sine? Negative cosine of the blob. Close, close, plus c. And now we simplify it to just 1/2 cosine of cosine of 2x plus c. And that would be how to write it with the fewest number of parentheses. So the trig function can be the inside function as well as the outside function, and therefore the rule of integration. It's 2 separate tasks. Okay? Looking good. A, B, C, D, E comes next. Whoa! Whoa. Skip. Yep. All right. This is like the first time we've seen a quotient, isn't it? We have something divided by something. So we're kind of trained to analyze factors side by side in the numerator. So what I would recommend is, if you don't see the insight right away, is to bring all factors from the denominator to the top by putting them to the negative power of what their exponent is in the bottom. Now the other thing that you want to kind of notice is you got a factor of 2 in the top and 3 in the bottom. Don't let them influence your antiderivative. Bring them out front, 2/3, and then we got a sine of 2x in the top. And in the numerator, we'll have cosine squared minus sine squared to the, if we get rid of the radical and bring it to the top, it's to the negative 1/5 power. And now you can compare them like we've been doing. Which factor has more info? The second one, right? Obviously. So again, walking up to it from the outside function is blob to the negative 1/5. So that would be a power rule of integration eventually. But you can't just go right to the power rule, right? Because the first step of integration like this is to check the derivative of what you're calling the inside function, which is that. So now the derivative of cosine squared minus sine squared. There's a problem there, isn't it? We have a single angle here, cosine squared of 1x, and we're trying to say that its derivative in conjunction with the other term is going to give me a sine of 2x. Ugh. Ugh. Yeah, we got to do something, right? So here's the part where it doesn't fit what we've previously seen. So we have to change it to something we do recognize that we have seen before. And of course, when you have trigonometric identities are always in play. And so cosine squared minus sine squared is not Papa-Pid. It's not 1. That would be if they were both positive, it would be 1. Or if they were both negative, it'd be negative 1. I did hear it, though. Cosine squared minus sine squared is equal to cosine of 2x, yeah. And that's one you need to know. It's the double angle identity for cosine. So let me go ahead and highlight that so that you can make the connection. And remember, the other one is sine of 2x is 2 sine x cosine x. All right, so now it looks like something I recognize. The derivative of cosine of 2x is not surprisingly negative 2 sine of 2x. We get the variable part, we're off by a negative 2. So the 2/3 goes along for the ride. We'll have a correction of negative 1/2. And now the rule of integration, right? The power rule. Blob to the negative 1/5. Leave a little space, becomes blob to the what? When you add 1, you add 5/5, you get 4/5, good. And then instead of dividing by 4/5, we typically multiply by its reciprocal, 5/4. And we put plus c. Now, even if that's not your final line, if you have plans on rewriting it and putting the plus c on the very end, if you don't put the plus c here on a pre-response, you'll lose points. It has to be correct all the way down, not just at the end. So now if we combine everything, we get negative 5/12 is our coefficient. We could say it's the 5th root of, and we could put the 4th power back in the condensed form, plus c. So what I was saying above is if you do that, you found the antiderivative. I know that's not my final answer. Here's my final answer. Okay, great. You're going to lose a check right there. Why? Don't do that. Don't whine. Don't whine. Just get on board with the program. Yeah. Yes.
If you took the derivative of cosine squared, you could do that.
You want to take the derivative of that? Let's see what we would get. By the power rule, we would get 2 cosine of x to the first times the derivative of cosine, which is negative sine of x. And then minus the derivative of sine squared would be 2 sine of x to the first times cosine of x. And you get negative 4 sine x cosine of x, right? Which is the same as negative 2 times 2 sine x cosine x, which now is negative 2 times, what is this equal to? Sine of 2x. And now you could say, I'm only off by a negative 2. That's fine. It works that way. You can still get the same right answer. Yeah. It's a matter of like, that's fine. No. I was wondering if anybody was thinking that, and you weren't. So it's a matter of changing it on the front end or changing it on the back end. And typically, if you change something on the front end, it makes it a little bit easier, but it does work. Now, if you did that, I would probably do this off to the side. That's your bench work, right? You don't do it below the problem to interrupt the flow. The flow of the problem should be equivalent from low to high without equal sign. So if you have to do something off to the side, that's exactly where you do it. Okay? All right. I'm glad you brought that up, Phipps. All right. So now I'm going to let you kind of toil with F on your own because there's a little bit of flexibility there, and I'm kind of curious to see what path you take. What? Maybe thought I was getting undressed. I don't know. Taking my jacket off. It's getting hot in here. Calculus burns a lot of calories. Gets your heart rate up. Yeah. If you don't get the calculus fever, give Katie a hug. She'll give you the fever. The flu fever. Which I just got over. No thanks. Mess with the lion, you get the paw, or the claw, or the mouse, or the mane. You get the mane. Yeah. Although Pedro would have been a good lion too with his old mane. Yeah. I can see it. I can see it. Okay, let's see how it's coming along here. If you have been paying attention or read the directions, I said every single one of these is going to have the same inside function. So if you went with that, you would then say, okay, cosine of 2x has got to be my inside function, right? That's what it has been. But then you're like, man, if cosine of 2x is the inside function, what the heck is it actually inside of? Itself. It's inside another cosine of 2x. Is that what you mean? Oh, yeah. Well, that's what that would mean, inside of itself. What is it actually inside of? It's inside of something to the first power. Very hard to see that, right? So here's another way to think about it. If you were to call cosine of 2x u, it would turn into the integral of u, which then you would say, that's just 1/2 u squared. So often the hardest outside function to see is the one that is implied there, that is not visibly there, something to the first. So adding parentheses and putting the 1 can help you see the layer. Now let's see. The derivative of cosine of 2x is -2 sine of 2x. We've got it, so the 11 goes along for the ride. We're off by a -2, so we'll have a -1/2 correction. And now the rule of integration is what? It's the power rule, right? Blob to the first becomes 1/2 blob to the second plus c. So add grouping symbols. And then if you simplify that, you get -11/4 cosine squared of 2x plus c. Got it? But wait, there's more. As Katie was over here trying to encourage a sign revolution, there's another way to do it involving sign. So let's see what that would look like. If you wanted to say, hey, maybe sine is the inside function, and you'd be like, what is it inside of? It's inside of something to the first, also as well, additionally, too. Let's see. What would the derivative of sine of 2x be? Well, that would be +2 cosine of 2x. And now you do get the cosine of 2x, and you're only off by what type of 2? Santi, what type of 2? Say it. +2. So I made him say the word positive. There you go. It's like his kryptonite. So 11 goes along for the ride. We have a correction of +1/2. And now the rule of integration is still blob to the first. So it becomes 1/2 sine of 2x squared now plus c. And if you simplify all of that, you get positive 11/4 sine squared of 2x plus c. So, of the two answers that we got, which one is actually correct? Both are correct. Yeah. So how can it be that some function can have two antiderivatives that are different? Well, look at that differently. That's the same thing as saying, how can two functions that are different have the same derivative? We know the answer to that, right? It's possible for two functions that are different to have the same derivative. But if that happens, they only differ by a what? A constant, right? Like x squared and x squared plus 5. They both have a derivative of 2x. So here's what I want to do before we go on to the next one. I want to show that these two are actually equivalent, but for a constant. So the way I'm going to do that is I'm going to take my negative 11/4 cosine squared, and using Papa Pid, I'm going to replace cosine squared of 2x with 1 minus sine squared of 2x. Okay, so doing a Pythagorean substitution. If we then distribute, we get positive 11/4 sine squared of 2x minus 11/4 plus c. And now if you compare this one to that one, you can see that they do only differ by negative 11/4. Yeah, so we just showed it. So if you were actually working this problem and it was a multiple choice question, if you worked it out and got cosine, but the answers were in terms of sine, you could do this. You could convert it at the end. Now, how would you justify then, if this is what you got after you converted it, how could you justify to go with that answer? Engulfs it. That's a good word. Yeah. What is a number like negative 11/4 plus an unknown constant? It's another unknown constant, right? So we can call it new and improved unknown constant C. Yeah, 2.0. I call it the ShamWow C. Later on, I call it the ShamWow C because it's super absorbent. So if you have a number plus C, or a number times C, or C divided by a number, it can absorb that number into a new and improved C, right? Like the ShamWow can absorb pretty much everything, okay? Including their spokesman's career. It soaked it right up. He kind of went off the rails after he did that and beat up some girl and went to prison and kind of gave ShamWow a bad rap, right? People are like, I don't want to buy ShamWow products now because of that guy. But no, that was the guy that always wore the little headset, and he was kind of like, he kind of looked like a little rat. He's like, watch me spill my orange juice and clean it up, ShamWow. I don't know if you remember that. And then they go to commercial break and beat up his girlfriend and come back. He was a bad guy. Which is unfortunate because ShamWow, when you use it, it's kind of like, wow, it's super shammy. It cleans it up. But anyway, ShamWow C, it absorbs other constants. It doesn't absorb unknown variables. It absorbs constants that are added or multiplied by it. Okay, example 7. Evaluate secant squared of tangent of x two different ways and show that they only differ by a constant. So kind of what we just did. All right, so if you look at this one here, you're like, what's up, two factors? Well, yeah. If you're not sure what to do, write things in expanded form. You have secant of x quantity squared times, and now you could, this little trick, tangent of x to the first, right? The more interesting factor, the one with more information, is actually the first one now, right? So let's see if it works. If the outside function is blob squared, maybe secant of x is the inside function. What's the derivative of secant of x? Secant x tangent x, and we only have a tangent there. Bummer. So here's one that doesn't work that way. So the only other option then is maybe tangent of x is the inside function. It is inside something to the first. What's the derivative of tangent? Secant squared. We got it. So the secant squared gets packaged up with no correction, becomes 1/2 tangent squared of x plus c. So that's one way to do it. Here's another way to do it. And some people think this way. Another way to write secant squared of x besides secant x quantity squared is secant x times secant x, right? Times tangent of x. Now, why would you want to do that? Now you're making it into a triple product. Yeah, very good. Because now, if you put the secant of x with parentheses around it to the first power, now secant of x could be the inside function. What's the derivative of secant of x? Secant x tangent. It generates both of the other factors. That's kind of a rare thing. It works with secant and cosecant. It generates both of the other factors. So with no correction to make, it gets packaged up. It becomes 1/2 secant squared of x plus c. And now, we're kind of like we were before with Pythagorean trig functions. 1/2 tangent squared of x plus c and 1/2 secant squared of x plus c are not the same function. They do have the same derivative. And if you wanted to use baby PID number 1 to convert one in terms of the other, you could see that they only differ by a plus or minus 1/2. Right? And remember, that identity is this. 1 plus tangent squared of x is secant squared of x. And, of course, 1 plus cotangent squared of x is cosecant squared of x. So kind of good to review those every once in a while. All right. So sometimes you have the flexibility. We've seen that a couple of times today to get equivalent answers. But if it's not the one you want, you can convert it after the fact or force yourself to retreat back to the beginning and look at it a little bit differently. Regroup things, something like that. All right, we got 4 minutes left for lunch. Let's look at example 8a. It's about to get fun. Okay, we're crescendoing in fun. Yeah, oh yeah. All right, if you look at this one here, count the number of factors we have. How many have we? 1, 2, 3. Let's do it again, class. 1, 2, 3. Clap it out if it helps. 1, 2, 3. Very good. Tomorrow we'll count to 4. See, imagine if it was that easy. Okay, so anyway, which one of those factors has the most information? Yeah, the last one. Now, it's not always going to be the last one, but perhaps, right? Because when we like to write things for presentation, we like to write the factors in increasing order of complexity. So it's a good idea to start with the last one. So what would you call the inside function? 5 to the x cubed plus 7. Yeah, let's see if it works, right? We don't just want to assume it. What would be the derivative of 5x to the cubed plus 7th power? Well, it would be itself, right? 5 to the x cubed plus 7 times. Yeah, don't forget the natural log of 5. So that's good. We do generate the variable part. We generate an unwanted natural log of 5. So far, so good. But because our inside function has its own inside function, it would then be times the chain rule, 3x squared, which now that generates the x squared. We're only off by a 3. And, of course, the 4 that's there, he's already in your final answer. So don't worry about him. So did we pick correctly? We chose the inside function correctly? Yeah. So now let's go ahead and make our corrections. If I have an unwanted natural log of 5, I'll put its reciprocal there. And that's the one that a lot of students would forget. And if I'm off by a 3, I'll have a 1/3 there. At this point, you know it's going to work. So everything else now in front of the secant squared is all accounted for now in my answer. And I move on to the rule of integration, which is the outside function, secant squared. And now for the second time today, what's the antiderivative of secant squared? Tangent, yeah, of the same blob. And then you garnish it with a plus c. And you can simplify that if you want. I'm not going to do that. Or maybe I will. 4 over the natural log of 125. Is that right? Yeah, just keep that in mind. That College Board loves to play with logs. So 3 natural log of 5 is the same as the natural log of 5 cubed. Bring the 3 up as an exponent. I doubt they would do that, because that makes it kind of a large argument, but they certainly could. Okay, we'll stop right there for lunch on example 8a. And I guess after lunch, this one is waiting for us. We'll call this guy dessert.